Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, this week, it is a pre-recorded session. So if you do have any questions, if you're watching on Zoom, you can reply to the confirmation email you got. That'll go to my email box, and then I'll respond to those when I get back from traveling. If you're watching this on YouTube, just leave a comment under the video. Same thing. I'll get to those when I get back. And then on Facebook, you can just leave a comment underneath as well. And then I will get to those at the end of the session as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So over time, working at the dealership just became the go-to diag guy in the shop, I guess. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bag. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is body shop diagnostics. So I know over the last decade or so, body shops have been getting more and more involved in the diagnostic world, so to say. So back maybe 10 years ago, they were a little hesitant. I know there were some shops out there, that's back when I was a sales rep. So there's some shops that jump right on board with it. And there's other shops that are like, I don't really know. Nowadays, the way cars have been progressing with technology, a lot more body shops have been getting involved. And there's not so much of a sublet anymore. But there are still shops out there that sublet it, or maybe they have their own mechanical shop on the premise. Seen that before as well. So if you're a body shop technician, this will be a good primer for you. If you are a general technician or general repair technician that sublets the body shops, it might give you a little insight into some of the body shop things that go on with the estimating and things like that. So hopefully it'll be a little bit for everybody. But why do body shops need diagnostics anyways? If we think about, like I said earlier, vehicle complexity. How complex is a modern vehicle with hundreds of different modules, different networks, ADAS, all the different sensors and subsystems? Mandatory pre and post scans. We'll get a little bit more into this in a little bit, but manufacturers starting in 2016 said if vehicle is in collision, you need to do a pre-scan and a post-scan on a vehicle. And that leads us to documentation as well. They need to document everything that either needs to be done or has been done on that vehicle. They also need access to repair information, not just the, well, here's where this body panel goes sort of information, but also wiring diagrams, repair and removal and replacement. Let's say it gets in a front end collision and it takes out the front timing chain cover. They'll need to know how to replace the timing chain and so on and so forth. So there is a lot of crossover between the body shop and the general repair shop, especially nowadays. And then, of course, there's relearns and calibrations as well that need to be done. Think ADAS or really many other replacement on the vehicle. We're going to talk about a few of those as we talk through tonight. So as we said, vehicle complexity. There's more than 100 modules on a vehicle sometimes. Everything's a module now. The door switch can be considered a module, considering all the different networking that we're using on a vehicle. It could be a LIN controller. Vehicle technology on average changes about every 38 days or so. It's roughly once a month we get a new system or a new technique or something of that nature that gets rolled out in the automotive world. And of course, many vehicles nowadays have ADAS features as standard. They used to be optional. You could pay for them. But now a lot of the vehicles just rolling off the line automatically have a camera, a radar, an ultrasonic sensor on that vehicle to allow for the advanced driver assist system. And there are many different methods for repair and diagnosis. If we think about how to repair this system on a Nissan, might not be the same way we repair that system on a Chevy, and so on and so forth. Different manufacturers have different ways of going about it. So they need to be able to go through a nice workflow. Talk about vehicle complexity. So windshield wiper controller. So there's sensors for that. Adaptive front lighting, cruise control, automatic braking, electronic throttle control, power steering. Electronic valve timing, tire pressure monitoring, that's definitely important for that. Lane correction, battery management, entertainment, all of these different systems and subsystems on these modern vehicles. And I think if you're a general repair, you already understand what I'm talking about there. The vehicle is just a rolling network of computers at this point. And that brings us to mandatory pre and post scans. So back in 2016, because of this, really, because there's so many modules on a vehicle, and some modules can set codes that don't have lights, manufacturers began mandating mandatory. So mandating would mean mandatory pre and post scans after a collision. So when a vehicle gets in a collision, you have to do a pre-scan when it first comes in, see what the state of the vehicle is. So that's going to show the vehicle condition on arrival. Then we'll do the repairs, and then we do a post scan at the end to verify that those repairs have been completed. So here's just an example. Pretty much every manufacturer now has some sort of a position statement on this. And a position statement is just, hey, here's how we feel about it. And they all pretty much want you to do it. So this really does apply to general repair as well. You would want to do a pre and post scan, but it's very important in the body shop world. So here's an excerpt from Toyota. So considering the fact that a capable scan tool is the only way to identify some DTCs, Toyota requires that repairers perform a health check diagnostic scan if a vehicle has sustained damage as a result of a collision that may affect electrical systems. And if we think about a modern vehicle and there's modules everywhere and they could be kind of close to the outside, or at least the wiring harnesses could be running through the fender and so on, yeah, it could affect the electrical system pretty easily. Additionally, Toyota strongly recommends that repairers perform a health check diagnostic scan before and after every repair to identify and document DTCs. So that's really more in the general repair. If DTCs are identified pre-repair, then they can be considered to create a complete vehicle damage analysis report. So they do need to do work up an estimate before they start. If DTCs are identified post-repair, then they can be diagnosed and addressed before returning a vehicle to the customer, right? So this is a lot of the things we've been talking about. And Snap-on's been doing full vehicle pre and post scans since 2014. So the last, 8 years now? Holy cow. The last 8 years we've been doing this. Now, we made improvements along the way as we go, but it does give a comprehensive vehicle system report. And that is available on any Snap-on scan tool that we have out there that we can still continue to update. Gives you the date and time stamp that the scan was performed. That's important. Most insurance companies are going to want to see that. Okay, when was it done? Date and time stamp. Also important, the VIN of the vehicle. So that'll come through if we do auto ID, or you can type it in manually as well. And then we could also customize it with our shop name, address, etc. If we scroll down a little bit further, it gets our overall health by system. So this gives us our color-coded overview. So green means good and yellow means worry about it, caution, and so on and so forth. And then we come down to the bottom. It gives us the actual detail here by system. So we had 3 yellow triangles, and there's the codes that I had there. And then, of course, we have the status of the readiness monitors down here on the bottom, which is very important, not just in vehicles, vehicle emissions states. So for the emissions inspection, you have to have your readiness monitors passed, but also to verify that you hopefully won't be getting a comeback on this particular problem. If you go through the road test and you complete all the readiness monitors, then you can be sure that, well, it passed that test. So it shouldn't set a code the next time we drive it, unless it's a multi-trip failure or it fails during that next time driven, of course. And it's not so much of a big deal nowadays. It used to be more of an issue back 2016, 2017, when it first started with these pre and post scan mandates. But we would always get asked, well, how am I supposed to pay for this? How am I supposed to charge for this? And nowadays, most insurance companies they're so used to it now. They're just like, oh yeah, well, give me the pre-scan, give me the post-scan, and we'll pay you half an hour or an hour, whatever. Depends on the insurance company or the adjuster, I suppose. But they definitely pay for it. And some body shops, it's gotten quite a good income stream for them. Just doing the pre-scan and post-scan. I'm just going to buy a scan tool just so I can do that, let alone actually diagnose the vehicle. There was a high volume shop we looked in, and they were checking just one with the volume that they do on every vehicle that came in. You have to do a pre-scan and a post-scan, and there was like $100 a scan or something like that. They were making hundreds of thousands of dollars a year just from that one shop because they were a super high volume shop. So that's over and above anything else that they need to repair. So more than covers the cost of the scan tool for sure. So it's less of an issue than it used to be. There's some body shops I've talked to, they say, yeah, we do a pre and post scan. And sometimes, depending on the vehicle, depending on how messed up it was, maybe we get to a certain milestone and then we clear out the codes and then we rescan it and see if anything else is there. And if so, then we fix that and so on. So it's like an intermediate scan in the middle as well. So lots of ways to do it. Insurance companies are pretty open to it at this point because they're used to it right now. So not much to worry about there if that's a concern. Also, with our pre and post scans, they automatically get uploaded to the Snap-on cloud, so they can then be shared with the insurance company or the insurance adjuster or the customer right from there. Works on a phone, tablet, PC, Mac, laptop, desktop, doesn't matter what it is. As long as it has a web browser on it, you should be able to get to that website and you should be able to share it from there. It kind of made it nice and easy for us so we can share it. So once we've done the pre-scan, next thing we need to do is the actual repair, right? So once the vehicle is scanned, the repairs can begin. Body shops do need access to vehicle repair information, not just the body work type repair information, but wiring diagrams, removal and installation, estimation. So I need to know how much if I got a busted mass airflow sensor, I need to be able to put that in my estimate, right? So most body shops do already have existing estimating software, at least for the body portion of things, but having the parts and labor guide is a big help as well. So how the process works is pretty much the same as it would be in any general repair facility, except we're using different software. So the vehicle comes in and then we scan the vehicle, of course, because we need to do that pre-scan right away. And then you can enter that information into the estimation system. So that'll be the two most popular ones in the body shop world are going to be CCC1 and Mitchell International, no relation to Mitchell 1, by the way. Once the estimate's been approved and all that, we go and repair the vehicle. And then once the repairs are done, we go to a post scan and then we enter all that information into our software, do the final bill, and then we can release the vehicle to the customer through that. So the nice thing though, is that estimating software, since it is Windows based, can be installed on a Windows scan tool as well. So if you have a Windows-based scan tool, you could install your estimation software and have kind of your own one-stop shop for estimating. There's been some body shops, they buy the workstation there, so they have the big screen. They put their estimation software on there and they can walk through the estimate, including the pre and post scans, attach those all up. There's also as a camera on there too, so I don't know if you'd be able to utilize it with the software, but you could at least take a picture and attach it, I would imagine. So it can kind of be an all-in-one. You can walk around with it. You can have your estimation software right on the tablet as you're walking around the vehicle. So lots of good uses for that, I would think, in a body shop for that. Plus, they need access to repair information, right? So first things first, fast track intelligent diagnostics. If they have a tool with that, that will give us the access right from a code. So if I get a code, I click on that and it gives me the information I need related to that code. So we have TSBs on hand, top repairs, data, functional tests, guided component testing, and real world SureTrack experience as well, based on real world repair orders. So having that repair information right at their fingertips is pretty handy. And then of course, optional ShopKey Pro. We need information on more TSBs, specifications, testing, component connectors, component locators, removal and installation, the estimator like I spoke of earlier. And of course, the wiring diagrams as well. I need to know if this vehicle is broken, how am I going to fix it? Where are the wires? What wires do I need to check in order to figure out this problem? How about, well, I got a broken component and I need to test that component as well. So we have the built-in guided component tests in some of our tools as well. That would be very useful in that case because it tells us where it is. It tells us what the pattern is supposed to look like. It gives us the connector view information. So to give you an example of where you might utilize this as a body shop, it's a story that a body shop told us. They said, well, we had a 2016 Town and Country and it got hit in the driver's side front, kind of pushed the wheel back and all that in the fender area, kind of got smushed back and we weren't able to start it. We were having trouble. It was throwing codes for throttle body as well, throttle sensor. So we went to guided component tests. And if you don't know about guided component tests, it's a database of over 5 million guided tests for components on vehicles, goes all the way back to 1981. And it covers multiple systems on the vehicle. You can see in this town and country, we've got ABS, body electrical, charging, driver aids and ADAS, HVAC, starting and transmission, and of course, engine as well. So we can go in there and we'll look up the component or subsystem under there. So throttle control systems there. And then we have a throttle position sensor. And then we have the component information. Every component has a list of information. So in this case, this system uses 2 throttle position sensors. As the throttle opens, both of these signals will vary accordingly. These sensors measure throttle opening and position. They're used by the ECM to calculate engine load and compensate fuel delivery accordingly. There's one 5-volt supply and one ground with 2 signal circuits. The signal voltages change in opposite directions while throttle opens. So number 1 is going to go from 0.5 volt to 4.5, and number 2 is going to go from 4.5 down to 0.5. In turn, the PCM expects the values from both of those to equal 5 volts at all opening ranges. So if I add 0.5 to 4.5 when it's closed, that's 5 volts. If I see 4.5 volts and 0.5 volt there, when it wide open throttle, and that's 5 volts as well. So it wants to see added together in sum, those 2 signals give me 5 volts. And if we go down, it's going to tell me where that is. It's connected. It's located at the throttle. The best place to test it is at the throttle body, and TPSs are located in electric throttle control module on the side of the throttle body unit. Also have a couple connector views. In this case, we also have a PCM connector view, because we want to make sure if the signal is making it to the PCM or whether or not the motor can control. So they said, all right, well, maybe we can test the PCM. Where's the PCM? So they go back to the list. They go to PCM. They have a module location. And right there, located in the left front fender well, inner fender liner must be removed for access. So some manufacturers, like Chrysler, like putting their modules in places that maybe a standard module wouldn't necessarily be, depending on your manufacturer. But if it got hit in the left front, it's probably hit that computer. And that's probably why we're having a problem getting to this computer or getting the vehicle to start at all. Left front fender well, inner fender liner. So that means it's in there, probably got smushed. So that was just one example of where you might find that information. Once the repair is finished, though, there's often a calibration or relearn that needs to be done. So some examples like re-zeroing an occupant detection sensor. So in the seat, there's a sensor for that. If you move the seat so much as crack the bolt on the seat sometimes, you need to re-zero that and make it work. Make the system be able to detect the occupant. Sometimes you need to recalibrate window motors. So you put in a brand new window motor or regulator assembly. Sometimes it's just a combination of holding up and down on the window button, but sometimes you need a scan tool for it too. Headlights. How about re-aiming front cameras? If I replace a windshield glass, I need to re-aim my front cameras. Calibrate blind spot monitors. We got radars all over the car, and usually they're in the bumper. So if I get hit on the bumper, I probably have a damaged radar sensor on that as well. So you need to recalibrate those too. Here's an example of a seat calibration on a Mercedes. So 2016 Mercedes, they actually had a recall on this one as well. But the following procedure will guide you through all steps required to perform a complete initial startup of this weight sensing system. Process must be performed after any work on the front passenger seat. Any work. I take the seat out. I so much as move a bolt most of the time. We need to make sure there's nothing in, on, or under the front passenger seat. Front passenger seat must be moved to approximately the center position, both vertically and horizontally. So that's a little different than other manufacturers. Other manufacturers have you put the seat back all the way up and the bottom all the way back. It's kind of just crushing it into the back there. And that'll give you your setting. In this case, it wants it about centered. So centered in the front to back, centered up and down. So got to make sure you read through these procedures. So by the way, these systems, just about on every car nowadays, and it's used to decide whether or not the airbag needs to go off in a collision on the passenger side. So we think about, if I think back to Subaru, back when they first started using these systems about 2005, when they changed the body style on the Legacies and the Outbacks. And what happened was the dashboard on those prior had a panel that would pop out when the airbag popped out on the passenger side. The panel pops out and the airbag pops out, and it does what it's supposed to do. When they changed the body style, they changed the dashboard, and now the dashboard kind of just rips in half to let the airbag out. So there is no panel, so to say. It's just all one seamless dashboard on the top. So if there was nobody else in the car and it was just the driver got in a collision, both bags would go off, and then you would have this, you'd have to replace the whole dashboard as well. Whereas with the system and this system in place, if it doesn't sense somebody in the passenger seat, then the bag doesn't go off, and then you won't have to make those extra repairs and spend that extra expense to replace the whole dashboard and everything else. So it saves time, it saves the customer money, all good things. And then it also reminds you if they need to put their seatbelt on, which is another thing with that. So that's what they use it for. Let's see, corresponding belt buckle not fastened. We need a special tool, which I'm going to show you in a second. Turn on the ignition and go through the following steps. The 0-point setting, function check by applying weights, which is that special tool, must be placed on the seat sitting surface at a distance of 2.5 to 5 centimeters from the backrest. Going to erase faults, and we're going to check the component for the indicator lamp. When the function is ended, the fault memory is erased, and initial startup must be completed successfully. So if we go through this, it's going to walk you through it on the scan tool, and then it has you put this artificial mass in there. So it's a weighted mass to a certain weight. In this case, looks like 37.5 pounds, 17 kilograms. Goes on the seat, and that's to verify that it works. So you do it after the 0 calibration, and then you put it in there to test and make sure that it senses the weight in the seat. Most manufacturers nowadays don't require this, but some of the older models will. So in this case, this is like a 16. So that's actually kind of new for that. But like I remember Subaru, the first couple years, we had to use a special tool like this, and because it was weight sensitive. You had to set it to a certain weight, and then it would calibrate to that weight. A couple of years down the road, they went with a different system. It's more like a bladder, and you just zero it out. So it's a zero sensing, and that's what most manufacturers have gone to now. Seems like they're just in a zero state. So just put the seat where it needs to be, where we tell you where it needs to be. Hit reset, and it'll just zero it out, and then that's telling it there's 0 pounds. Anything over and above that, it'll know the weight, and it'll turn on the airbag accordingly. How about ADAS recalibration? So this is on a 2017 Genesis G80, and it had a collision, had a radar. It's got radar all over it, front and rear. But it needed to do a radar calibration. Car got hit in the front. So this is from a friend of ours, Mike Reynolds, down in South Carolina. He's a mobile guy, and he does mobile ADAS as well as mobile pre and post scans. So in this case, we have our radar module right here, and it needs to be 90 degrees perpendicular to the ground. And then we also need horizontally, kind of left to right, it needs to be level as well. So here he is performing the measurement with his digital angle gauge. And we can see 90 degrees straight up, all good there. And then this is this is less of a critical measurement, the kind of the rotational measurement left to right. In this case, it's 0.2 of a degree down on the left. So that's within spec. So that was okay. Next thing he wants to do is break out the scan tool, go into service resets and relearns menu, and go to replace or calibrate the front radar, because we have one underneath ADAS here for the radar. Go into functional resets and SCC alignment calibration. So SCC is smart cruise control. The purpose of this function is to align the sensors if sensors are replaced or the vehicle has an accident with structural damage that required wheel alignment. So if I even needed a wheel alignment, I need to do this. So it needs to be done when the radar sensor is changed. In case of light contact accident or strong shock against the sensor, front vehicle is not detected while running on the road, or steering angle sensor replaced or calibrated. We want to have no codes, and the ignition needs to be on. I thought this was interesting as well. So they give you an option to do either a static or a dynamic recalibration. A static would need a target. Dynamic, we're just driving it down the road. So that's the one he chose. Attach the radar sensor, make sure it's perpendicular by a tilt meter, turn the key on and connect diagnostic tool and vehicle and execute the alignment adjustment. Check the red warning line, the cluster turns on, drive above 50 kilometers an hour for 10 to 15 minutes. Avoid excessive steering, low speed driving, driving on roads with few obstacles, and driving in bad weather. Continue. This other screen was interesting as well. So it says the calibration process is started. Basically, you're putting it in a learn mode. And then you can disconnect the diagnostic tool and drive the vehicle. So you can leave the tool in the shop while you go drive and do this calibration. The warning light will turn off automatically when the alignment calibration is successfully completed. So continue there, drive the vehicle. And we can see we got the warning light right there. And then driving down the road a little ways later. So we had 455.9 miles, end up at 473.9 miles. So that's what, 18 miles? 18 miles, I think, from there to there. So we have it driving around and yeah, going 65 miles an hour, got the cruise control on, everything's working the way it should. Then of course, once that's done, we want to do a post scan to verify the repairs are complete, like we said. Once complete, the vehicle can be delivered to the customer and you can feel confident that the repair was completed properly. So that is very important to do those pre and post. Now let's go live on the tool. Close this out too. Okay, so a couple things we want to go through. We got a couple vehicles we're going to look at. So first one I want to do is this BMW. We got a BMW 2014 BMW 5 Series. I'm going to go through here. There's a few things that we want to talk about. First one's going to be we can walk through here and come down to ADAS and driver's aids here. And you see there's multiple things we might need to reset on this vehicle that gets in a wreck. All around vision camera, active cruise control, camera-based driver support system, lane change warning, all of those things more than likely need a reset or relearn, something like that. Come down here to body. We got a few things in the footwell module that need to get done. Come all the way down here to my lighting. So for example, front headlights. Got codes and data. We also have functional tests on the lights on this vehicle. There's a special function in here for teach in front light electronic turn signal. So if we change the light, we got to teach in the turn signal. So we need to do a relearn for a turn signal on this BMW. So if we hit continue, it's going to go through. Once you have the new unit installed, it's going to take maybe 10 seconds or so. It's going to walk through and do a relearn. Things as simple as a turn signal need to get changed or need to get reset, relearn. Let's see what else. So we can do active cruise control. That should be a radar, I would think. Functional tests here, special functions. It'll be a startup function. Okay, we need to check part of the startup. Absolutely necessary to proper function of active cruise control. Trouble-free function of active cruise control. The sensor must not be covered by a license plate or license plate carrier. Even a partially covered sensor can lead to limitations of the active cruise control or misalignment. So license plate secured in a license plate carrier. Yeah, it sure is. Let's see. Remove the installed license plate carrier permanently. This can lead to functional limitations of the sensor in the front camera. Make sure it's not hidden, and then we start the function. And then let's see. Vehicles fitted with air suspension. Control unit for the self-leveling suspension must be trouble-free and adjusted. Therefore, start the engine and wait until the air suspension is set for the control function of this air suspension to function properly. The doors of the vehicle must be closed. Switch off the engine. Continue. Rear axle slip angle control is installed and must be working and trouble-free. Is it working correctly? Yes. It can actually do a lot of different things. Steering wheel needs to be good. And then it'll go through the startup process. Okay, so a lot of different things that may need to be done depending on what the vehicle is equipped with. If I have to do it, if I have to recalibrate a camera, if I have to go in there and use a target to recalibrate the around view camera, that might be a thing that needs to be done as well. Next thing, we'll check out this Escalade, 2018 Escalade. And that one's a pretty well-equipped vehicle. It's got a lot of different things on there. So we have like parking brake control, tire pressure monitor. That's a big thing as well. Tire pressure monitor is the for the tires. We're actually going to be talking about it next week, but wheels and tires, you get into collision, wheels and tires for sure. How about passenger presence? All right, we got seatbelt tension sensor, presence sensor learn. So in this case, we need to remove all excess weight. Hit continue, and that one will just runs through. That's just a simple re-zero. Mission key must be in the run position. It may not be in the run position. I'm thinking that's going to error out for me. That's a simulator for you, right? Just reload that escalator real quick. So once again, we got active safety, parking assist, camera system, radar sensors, long range, short range, front and rear. It's got radars all over the place. It's got 5 different radar modules, side optic detection module, assist step. So if I get hit on the side and I have the electric step that comes out, got to do that. How about liftgate module? So we can do a liftgate sensor control module calibration for the hands-free liftgate sensor. So that's where you put your foot underneath. Applies to vehicles only equipped with this feature. Turn the ignition on, and then it just goes through. This is going to take like 10 seconds. It'll be a simple reset. But if that sensor was replaced, that needs to get calibrated. How about the maximum open position learn? So what that's going to do is we're going to start with the all the doors unlocked and lift gate closed, and it's going to lift and lower the gate, the electronic rear gate. So it's going to go through. It's going to have the little couple data points here to start. And then it's going to continue through, and it says caution, the lift gate will be opening now. So you continue, lift gate will open. It's going to go through its thing. And then I'll say lift gate will be closing. Ensure the lift gate area is free of any objects. We'll hit yes. It's going to go through. And then it'll give us a pass fail right here. So in this case, we got failed there. And then we got passed, and all this is just demo data anyways. So, but in the real world, you should see passed on all. Okay, and then last one we'll go through is this Hyundai. And that has a seat calibration that'll work. Let's see, so we go down to doors. Seats. Wait, no, occupant detection. Never mind. Occupant detection is a common selection. All right, there we go. And then we have system test and occupant detection. This is PODS reset. So PODS stands for Passive Occupancy Detection System. This function is used for initialization of the PODS ECU, and it tells us what kind of seat is installed in the vehicle. Perform the PODS reset when the front passenger seat is empty, and remove all items from the seat that may have caused the failure. After turning the ignition key off and on, try again. Please select the reset mode in the next step. The auto mode is selected when replacing seat assembly or the seat foam itself. Then the manual mode is selected when replacing the ECU itself. So I continue, we'll do auto. It's going to do a test in progress, and it's done. It doesn't take very long at all. It takes mere seconds to go through and reset it. And that is a re-zeroing function. So that is the back is all the way forward and the bottom is all the way backwards. It's kind of like a leaning forward seat. Re-zeros the seat and allows it to carry on. So with that, that is the end of class for this week. So let's talk about next week. So next week, we'll be starting a part 1 of a 2-part series. It's going to be on code-based diagnostic workflow. It's always good to have a nice repeatable workflow that you can work through when you're trying to diagnose a vehicle. So make sure you join me. Same time, same place, 6 and 9 Eastern. If you want to join me on Zoom, you can go to snapon.com/OT and reserve your seat there. Also, the 6 p.m. Eastern class goes to my YouTube channel. So if you're watching this on YouTube, please make sure you subscribe and give a thumbs up. And it's youtube.com/Snap-on Diagnostics if you want to watch it there. Also, the 9 p.m. goes to my Facebook page. So if you go to facebook.com/SnapOnJason, all one word, no dash in the Snap-on, you can go follow me there. If you want to see any of our other prior classes that we've done, anything from ADAS, data bus testing, component testing, basic electronics, forced induction, etc., all available over on the YouTube channel. There's a separate playlist just for live training. And with that, we're up to Q&A. Now, as I said, this is a pre-recorded session this week. So if you do have any questions, if you're watching on Zoom, just reply to the confirmation email. That'll go to my email inbox. If you're watching on YouTube, just leave a comment under the video and we'll help you out when we can. And then same thing with Facebook, leave a comment under the video and I will get to those as we go throughout. Also want to make sure I mention my buddy Al, who also does free diagnostic training. He does tool-specific training. So if you want to get a little bit more knowledge as to what your tool can do, how it works, Monday it's on Apollo, Wednesday it's on Zeus, and Thursday it's on Triton. So very thorough class all the way from let's make sure your Wi-Fi set up Make sure that's all set and going, because a lot of features on the tool actually need Wi-Fi nowadays, and that's through the manufacturer even. All the way through, let's set up your free Snap-on Cloud account so you can upload and share files, and then we'll go through code to completion, fast track intelligent diagnostics. How does it help me as a technician diagnose vehicles faster? And then that's about an hour long for all that. Each night, depending on what tool it is, he'll just do it on the respective tool. Wednesday and Thursday, though, since those tools also have scope and meter functions, take a 5-minute break after that first hour. And he goes through another hour on the scope and the meter and real world examples of where he would use that and what it would look like, fuel pumps, things of that nature. So same time, same place, Monday, Wednesday, or Thursday. Pick your tool, snapon.com/OT. He only goes to Zoom, so you'll need to be, it's more of an in-person type session. Your camera's not on, but he'll be able to answer your questions. You type them in the Q&A. He's definitely able to answer your questions live, and it's kind of designed to have the tool in front of you following along with what he's doing on the screen. So once again, go check him out, snapon.com/OT. It's free. With that, thank you very much for your time today. Thank you for taking a little bit of time out of your busy week to come join us. Hopefully you picked up a few tips and tricks on the capabilities that you have to diagnose motorcycles, and hopefully maybe add that to your repertoire if that's something you want to do. If not, maybe you got a little bit more information on what the capabilities are anyway. So with that, thank you very much, and we'll see you next week. Have a good night.